In example 2, we have 4 functions that we are asked to sketch the graph of using point-by-point plotting. So one thing to keep in mind, when we are sketching the graph of a function, the idea is if we take any point on the graph, the x-coordinate for that point should be interpreted as an input for the function, and the y-coordinate of that point is the resulting output. So when we use point-by-point plotting, basically what we're going to do is choose several different values for the input, plug all of those in, treating them as x values, and then the outputs that we get back out we treat as y values. Each x value and resulting y value gives us 1 point on the graph. So looking at the first function, f of x equals x squared minus 8x plus 12. If we want to sketch this, like I said, we need to first come up with several different inputs to plug in. So I'm going to build a table here so I can keep track of my inputs and my outputs. My inputs are going to be x values, my outputs are going to be y values. And let's just choose several inputs like 0, 1, 2, 3, 4, 5, and 6. There's nothing really special about these numbers. I'm just choosing things that, I don't know, might work out well. So when I plug in 0 into this function, f of 0 is going to give me 0 minus 0 plus 12. You can run through and double check that yourself, but if I plug in 0, I get back out 12. So that means the point 0, 12 is a point on the graph. So as far as scale, I'm going to use each one of these blocks as being 2 units, just so I can fit the graph on here. So I have my x-axis here and my y-axis. So if each block is 2 units, then this would be y equals 12. And so the point 0, 12 would be right here. So that's my first point. Now I plug in a second point, a second value. I let x be 1. If I plug that in, I get 1 minus 8 plus 12. So that turns out to be 5 if I calculate that all out. So you can go through and verify that on your own. But if I plug 1 into this function, I get back out 5. So plugging in 1, let's see, this is 2, 4, and so 5 would be right around here. So I get the point 1, 5 on the graph of the function. Okay, continuing on. So let me just go ahead and fill out the rest of this table. If you plug 2 into this function, you get 0. If you plug in 3, you get minus 3. And I definitely encourage you to go through and double check all of these yourself. If you plug in 4, you get minus 4. 5 gives you minus 3. And 6 gives 0. So when I sketch these points on the graph, I have the point 2, 0. So this is 2. Y equals 0. The point 3 minus 3. So that would be right here. 4 minus 4. So this would be x equals 4. This would be y equals minus 4. So we're talking, our point would be right here. 5 minus 3 would be right here. And 6 comma 0 would be right here. So this just gives us a few points. And then to get our sketch, we go ahead and more or less just draw, we connect these dots with straight lines. Really, if you've ever seen parabolas before, then you can probably identify this as a parabola, and you can tell that line's not straight, but we're just getting a rough sketch of it here. So this is what we have so far. If I continue to plug points in, I would find out that I have a point here and a point here as well, which would let me extend the graph on out a little bit more. Okay, and that gives me this parabola. Later on, we're going to learn better techniques for sketching parabolas than this point-by-point method. But the nice thing about this point-by-point method is it reinforces what it means to have a point on the graph. Basically, the idea that the x-coordinate for any of these points is the input and the y-coordinate is the output. Okay, so let's go on and look at these other examples. So this is part B. And the function we are dealing with in this case is g of x equals minus 2 x squared plus 4x plus 6. So let's build our table with several different inputs. Now I'm going to go through this a little bit quickly and just choose a few inputs that I know are going to work out well, but you can go through and double check my work. So let's start off by choosing 0, 1, 2, 3, and 4. Now I'm going to go back and add a couple more later. But if I plug 0 into this function, I get 6. That should be relatively easy to see. If I plug in 1, I'm going to get 8. 2 is going to give me 6. And 3 is going to give me 0. And then if I plug in 4, that's going to give me minus 10. So plotting these points, with this as the x-axis and this is the y-axis, I get 0, 6. I'm going to use the same scale as before. Each block is 2 units long. 0, 6, 1, 8, 2, 6, 3, 0, and 4, minus 10. So this is 2, 4, 6, 8, minus 10 would be down here. And so the point 4 minus 10 would be this one. Okay, so if I go ahead and connect these up, I'm going to get a picture something like this. This is another parabola, but this one is sort of opening downward. Now notice I haven't plugged in any negative numbers. There's no reason for that. Plugging in negative inputs is perfectly fine. So let's go ahead and try a couple. Let's say I try to plug in minus 1 and minus 2. Well, if I go through and calculate this, minus 1 is going to give me 0 as an output, and minus 2 is going to give me minus 10 as an output. So if I plot those points, minus 1, 0 would be this guy. Minus 2, minus 10 would be down here. And so then I can continue my sketch out on the negative side of the y-axis, or for negative values of x. Okay? So that gives me roughly a parabola a little like this. Okay, moving on. Part C. In part C, we have this function with a square root in it. And C, you have h of x equals the square root of x plus 4. Now, at this point, I really encourage you to pause the video and go through and try to come up with a few inputs on your own and come up with a sketch of this graph on your own. Try to figure out inputs that will work out nicely. And if you have a calculator handy, then that will give you a little bit more freedom in choosing your inputs. But once you're done, come back and kind of compare what you've done with what I've done. And there's no one right way of choosing your inputs here. Okay, so like I said, I chose values that I thought would work out nicely. So plugging these in, the values I'm going to choose are minus 4, minus 3, 0, 5, and 12. If I plug in minus 4, I have minus 4 plus 4, which is 0. The square root of 0 is 0. Plugging in minus 3, I get minus 3 plus 4, which is the square root of 1, and so that's just 1. If I plug in 0, I get the square root of 4, which is 2. Plugging in 5 gives me the square root of 9, which is 3. And plugging in 12 gives me the square root of 16, which is 4. Now, I chose specifically inputs that I could see would give me a perfect square, or would give me a nice whole number as an output. Again, if you have a calculator handy, you don't really have to do that. But without a calculator, that makes things a little bit easier here. And so, let's see. For my scale, I guess again I'm going to use 2 units per block. So x equals negative 4 would be out here. If I plug in negative 4, I get 0. If I plug in minus 3, I get 1. If I plug in 0, I expect to get 2. Plugging in 5, I get 3. So let's see, that's 2, 4, 5 is right over here, and I get 3 out, so that would be up here. And if I plug in 12 12 is going to be way out here. I expect to get 4. Now connecting these, I'm going to get a curve that looks like this. One thing to notice here is I don't have anything on this graph to the left of minus 4. There's nothing out here because if I plug in a number smaller than minus 4, I'm going to end up with a square root of a negative number. For instance, let's say I tried to plug in minus 5. H of minus 5 is equal to the square root of minus 5 plus 4. That's going to be the square root of minus 1, which is undefined. I can't actually calculate it. So there are no points on the graph to the left of x equals minus 4 because those inputs don't have outputs. Okay, moving on to part D. In part D, we have the function k of x is equal to 8 over x minus 2. And again, I've gone through and chose specific inputs that I thought would work out nicely. So these are things like minus 2, 0, 1, 2, 3, 4, and then let's go ahead and go up to 6. So plugging these in, if I have plug in minus 2, that's going to give me 8 over minus 4. 8 over minus 4 is negative 2. If I plug in 0, I get 8 over minus 2. 8 over minus 2 is minus 4. Plugging in 1, I get 8 over minus 1 or minus 8. 2, if I plug in 2, notice I get 8 over 0, and I cannot divide by 0, so that is undefined. I do not get an output when I plug in 0. Plugging in 3, I get 8 over 1. Plugging in 4, I get 8 over 2. Plugging in 6, I get 8 over 4. So the first thing I noticed is that I did not get an output when I plugged in minus 2. So to indicate that, I'm going to put this dotted line here. This is what's called an asymptote. If you haven't seen that before, don't worry about it too much. We don't really work with asymptotes in this class, outside of this one example, maybe. So again, I have this dotted line at x equals 2 to indicate that I do not have an output there. So plotting the rest of these points, if I plug in negative 2, I get back out negative 2. If I plug in 0, I get back out minus 4. And if I plug in 1, I get back out minus 8. Plugging in 3 is going to give me 8, which would be up here. Plugging in 4 gives me 4. And plugging in 6 gives me 2. Now, honestly, for this particular example, the amount of information we have here makes it a little hard to get a full picture. So I would really want to plug in more points to get a better and better picture. But let me just go ahead and show you what the resulting graph does look like. And honestly, I wouldn't worry too much about this example. This type of example is good for illustrating a couple of points. But it's not really one we're going to work with a whole lot in this class. Those other ones we've seen are really a lot more important. Okay, so this graph sort of hugs along this dotted line and also along the x-axis. And the resulting graph looks a little bit like this.